This video is going to present the properties that we're going to need on a regular basis for the rest of this course. And these properties will allow us to prove statements of a geometric nature. It allows us to do so using algebra. So let's start with the addition property. For example, if I know angle 3 is equal to angle 5, but I want to add, let's say, 90 degrees to both of them. The fact that I'm adding the same thing to both sides is the addition property. Remember, the same thing. So what if I wanted to add angle 2 to both sides? Okay, I'm keeping the balance. I'm adding the same quantity to both sides. For the subtraction property, let's say I have an equation, a setup, a congruency, and I want to subtract the same amount. So let's say I want to subtract this from both sides. That's a subtraction property. So we're subtracting the same amount from both sides, or the same quantity from both sides. With multiplication, we might be multiplying both sides by the same number. So if I multiply this side by 2, I would multiply this side by 2. In this case, I would get 2BE is equal to, these would cancel out, 1 CE, which is CE. For division, it would be, as expected in algebra, us dividing by the same quantity to both sides. The reflexive property simply states that a geometric object or numerical value is equal to itself. So in this case, angle 2 is angle 2. It tends to be a lot more useful when you have triangles. So in this case, I have two triangles, this one right here and this one right here. And they both share the same hypotenuse of AH. So the reflexive property in this case might be useful to say AH is equal to AH. Now don't forget, we can also do congruencies, right? So we could say AH is congruent to AH. Because these properties of algebraic equality are also true for geometric congruency. You might be asking, Mr. Over, what is congruency? We've said it before, but we're going to say it again. Congruency is a super equality. Congruency means same value, same shape, same size. Symmetric property. So symmetric property, for example, if we look at this drawing here, it would be like saying line AF is the same as line FA. So it's a mirror image of itself. The transitive property is classic. It's really fancy. It looks like this, and there's a special order to this. There's a special order. So for example, in our drawing, let's say angle 1 equals angle 2. But we know angle 2 is angle 3. So because angle 1 is angle 2, but angle 2 is angle 3, I can make the conclusion that angle 1 is equal to angle 3. Let's break it down a different way. Let's say we make the claim that if I study, then I understand the material. But how does this all begin? If I study. Then we say, okay, if I understand the material, then I get good grades. So again, where did this all begin? It began with if I study. Where does it end? I get good grades. So the in-between doesn't really matter because it's following the right flow of order. So essentially, we could just say, cut to the chase and say, if I study, then I get good grades. That's the transitive property. It has to follow that order. The substitution property doesn't follow that order. See, it's not going from 1 to 2, 2 to 3. It's saying if 1 is 3 and 1 is 2. Okay, so if that's true, well, then I can say that angle 2 is angle 3. How come? It's because we're saying that angle 1 is angle 3, but angle 1 is also angle 2. Angle 1 is both of these things. So it could be whatever it wants to be. It doesn't matter because angle 1 is both of them. So if it's both of them, they're both equal to each other. You're going to want to make sure you know the difference between substitution and transitive because they're very related. They're like those cousins that look like twins, but you know they got different parents. So make sure that you can distinguish between the two of them. So with that being said, I want to point out a few key properties. The reflexive property is very helpful when there are triangles in a drawing. That's usually because there's a side that's being shared. The substitution property is almost always going to be used, and it's one of our bigger properties. The transitive property can also be seen frequently in proofs and tends to be a more sophisticated property. Of course, in order for it to be true, it has to follow this order.